All right, so reminder, we have 2.10 today and tomorrow. Your quiz is open through Friday. So those of you that weren't here, there's a quiz on College Board that is just for 2.8 and 2.9. Okay, so you have until Friday. I'll show you. Don't forget. Okay, so I mentioned yesterday when we started working with log functions that log functions are inverses of exponential functions. Okay, so in this first example, we are given an exponential function, which is y equals b to the x, so 2 to the x. We're also given its inverse. Okay, now you're just going to take my word for it right now that they are inverses of each other. In a minute, we'll actually do that, with other problems. I'll show you how to find that. We're just trusting right now that they did this correctly, okay? And we're going to graph both of them and see what they look like. So here we have an XY chart for our exponential function. They picked these typical -2 to 2 values for us to plug in for x. And so when I do 2 to the -2, I get 1/4, and I get 1/2, and 1, and 2, and 4. So we would just plug and chug those numbers right into the function. And I'm going to go ahead and sketch that graph, okay? Notice this graph doesn't have like all the nice pretty lines and numbers. That means we are strictly sketching. Don't stress too much about it. So to the left 2, up a little bit, left 1, up a little bit more. We have an intercept there at 0, 1, 1, 2, and 2, 4, okay? And we graphed exponential functions a lot earlier in Unit 2, and they look kind of like J's, the parent function does. And I want to remind you that we have an asymptote at y equals 0. Okay, so there is our function, y equals 2 to the x, okay? And it has a horizontal asymptote at y equals 0. So I'll just put this over here. That's one of the things I have on my list. I keep like a running list of common mistakes that I catch you guys doing like on tests and stuff. One of the things I marked wrong on a lot of your tests, most recent tests, was a lot of you would just write 0 for the asymptote. Make sure you recognize that asymptotes are lines, so you have to put x equals or y equals, okay? And we'll talk about that more. All right, so there's my purple graph on that graph. Now, we did a whole section, 2.8, on inverses, and 2.8 is part of your quiz. And I pulled the notes just to remind you, where you flip your x's and y's. And like we talked about, the domain and the range can be flipped in inverses because those are just x's and y's. We did it in xy charts, which we're about to do right now. We just flip the points. We did it in equations where we switch the x and y and solve for y. All of that stuff we're doing again today because logs and exponential functions are inverses of each other. So this is the inverse of this. And so instead of like plugging and chugging and putting a -2 in there and a -1 and simplifying this the way we learned yesterday or using our calculator, we can just flip these values, right? We can just flip them. So the y values of the exponential are the x values of our log. So I'm just flipping the xy chart basically. And let's see what that would look like. To the right 1/4, down 2. To the right 1/2, down -1. There's an x-intercept at 1, 0, 2, 1, and 1, 2, 3, 4, 2. And you'll learn today, I'll show you with some examples, that there is a new asymptote, which you could probably predict what it is. That's a terrible graph, sorry. But you have a vertical asymptote with this graph at x equals 0. Okay, vertical, so Vax and Hay. It tells us to also graph this, and if you remember, we learned that inverses are always symmetrical on either side of like this axis of symmetry called the identity function. And So we talked about that before. The identity function, it's called that because x equals y. Whatever you plug in for x, you get for y. And that's just a line with a y-intercept of 0 and a slope of 1/1. So if I drew this really pretty, you would have exactly the same distance on either side of that. Okay. So we're going to come back to the inverse part of this in a second, but let's dissect a graph of a log right here. This happens to be the same one we just graphed here, but let's pretend it's not. Let's pretend we don't have those points because this is exactly how you'll do it in your homework. And then on the test, grab your graphing calculator and go to your y equals and clear it. And we're going to put this in there. We learned yesterday how to put the logs in our calculator. So let's review that real quick. This log button is a quick button for base 10s called common log. So if the base is 10, you can use that button. But if your base is anything else, like 2, we had to hit these buttons. So if you weren't here yesterday, we did math, alpha, math. Math, alpha, math gets a log right there on your screen. Math, alpha, math. And then my cursor is on the base. I'm just going to put a 2 and arrow over to the x. Okay? Math, alpha, math. All right, let's see what it looks like. We already know what it looks like. We just graphed it. But let's pretend we didn't know what it looked like or what the points are. What you would do is go to your table. Okay? And if you notice, when I go into negative land, I get a bunch of errors on the y. I'm going to come back to that. What we're going to use from the table is just pick like however many number of points you need to kind of see the behavior of the graph. Like for example, 1, 0, that's a good point. 2, 1, that'd be a nice point to graph. I mean, I could graph 3, 1.585, but I'm going to skip that one and go to a nicer one like 4, 2. And maybe I'll do one more so I can really see the curve, what's happening over to the right. And I just kept scrolling until I found another nice point, 8, 3. So what I mean by nice, of course, is where it crosses a crossbar thing. Okay, now, you already know what's going to happen over here because I just told you, all right? I just went over it with you. But if you were doing this, like, and we're going to do one that we have never seen before in a second, how do you know where the asymptote is and what happens in here? Because I already graphed as close to 0 as I could, and there's nothing else. Everything smaller than 1 is error. So where that good point is, and then where the first error is, that tells you that's your asymptote. That 0, that's telling me that I have, that means that is an asymptote. And why is that helpful? Well, it tells me that there are points between 0 and 1. They're like little teeny tiny points. It doesn't have to be perfect, but I know how far to the left I can go. Okay? So I know I can't touch 0, but there are points between 0 and 1. And that kind of finishes the curve for us. Okay? So this is our function. Okay? Now, let's answer some questions about it. This is so important in this class. We've been talking about domain and range. This is end behavior right here in limit notation, which is the newest stuff, a little bit confusing. Asymptotes, intercepts, concavity, increasing, decreasing, all kinds of things, okay? We have to be able to look at a graph and pull that information off. And that's what we're going to do now. So, and students have struggled with this today. I was a little surprised. I'm not saying that to be mean. I just kind of thought domain and range especially was just kind of easy for you guys right now. And I'm kind of learning that we need to review that better. So looking at this graph, number, domain, are your x values. What are the x values that we will use in this graph? You kind of start with, is it all of them? Do we use from negative infinity to infinity? Do we? No. We will never go over here, right? This asymptote blocks us. It's saying, nope, you can't go over there forever. So we will use from, what number? What number am I going to put first? 0. Why not 1? Because there's numbers in between 0 and 1. So if I cut us off, if I say we're only using from 1 to infinity, I'm leaving out all of these little bitty points, okay? So we say from 0, but we use parentheses, right? Not including the 0. That means right directly to the right of the 0. We use those numbers, okay? How about the range? Well, as we go to the right, we're going up forever. Okay, so we definitely have all the numbers up. As we go to the left, are we going to be going down forever? Yeah, there's no vertical asymptote that's saying stop, you can't go any further. We can't go to the left, but there's nothing stopping us from going down. And it's hard for our human brain to kind of comprehend, how can this go on for eternity, right? And we still never get to zero. That's not for us to kind of worry about. It's mathematically correct, okay? So we will say from negative infinity to infinity on the range. Okay, limit notation to do our end behavior. Okay, so what they're saying is what's happening with this graph as x goes to the right. So that's that way, right? Going in this direction is positive infinity, right? So as we go in that direction, what are the y values doing? As I go to the right, what are we also doing? Going up, right? We go to the right and we go up. Up is also positive infinity, guys. So that's just as we go to the right, we are also going up. Okay? Now look at this notation. We've seen it like once or twice before. Same idea. What's happening with our graph as x approaches 0? And what does that plus sign mean? From the right. So if you need to write yourself a note, that means coming from the right. It's a one-sided limit is what it's called. That is because we can't get to the graph from the left. Remember, we're being blocked. You're never going to be over here. So you can only approach from the right. And what are we heading towards? They're asking us, where is this graph going? What are the y values doing as the x values get closer and closer to 0? What are the y values doing? They're going down, right? That's negative infinity. That's confusing. We're going to do another one in a minute. Asymptote, remember, this is a vertical line. X equals 0. Vax. Let's not get the x's and the y's confused. Vax. Vaxing. We have an intercept at 1, 0. Right? Yeah. And concavity, is this concave up or concave down? What you think? Is it going to hold water or dump water? Dump it. Yeah. Okay, let's do another one. And I gave you one of these to do in your homework. You're going to do it the same exact way. And your homework's really short. Okay, go to your y equals again. Clear it out. Let's see what happens when our base is a fraction. So I need to put the log with a different base in there, so that's math, alpha, math. And I'll just use 0.5, just easier. And then x. Let's see what it looks like. Okay. But I still need to use the table to get the base. Oh, I was thinking you were in the class and that you just went to the bathroom without asking me or something. Bye, Brandon. Okay, so let's pick some good numbers. Okay, I see. Look, there's those errors. But let's just pick some good numbers. I see 1, 0 is a good number. 2, negative 1. 4, negative 2. And 8. Negative 3. Okay, so we can see what's happening here. I can continue this. But I know, because of all those errors, that there is an asymptote somewhere. And if my last good point was 1, 0, the next point behind it, smaller than it, was at 0. That means that is my asymptote. Why is that helpful? Again, because then I can finish this graph, right? The points are going to go like that. Oops. Okay. So there's our graph. Domain is the same as the other one, right? From 0 to infinity, not including the 0. right? That's to the right. Now the range goes up forever, and as it goes to the right, it goes down forever. Those, we're going to use every single y value, up and down, okay? End behavior, okay, as x approaches the limit of the graph. So what are the y values doing as x goes towards positive infinity? So as we're going to the right, what's happening with the y values? Where are they going? Down. See how they're going down? That's negative infinity, right? Down is negative infinity. Left is negative infinity. And there's that approaching 0 from the right again. So as we head towards the 0, what are my y values doing? They're getting higher, bigger. Yeah, so infinity. Same asymptote. We have a vertical asymptote at x equals 0. Same y-intercept. But this one would be concave up, right? Right, so I gave you one of those to do in your homework. There's one last problem we have to do. This one has got a lot going on with it, so I want you guys to really pay attention. And this is where we're gonna really review how they are inverses of each other and some of the stuff we did yesterday. Okay. Okay. So there's a bunch of things we have to do here. We're given a log function, and they want us to graph it. And we're going to do exactly what we just did with all the other problems. Use the table and all that. Then we're going to find the inverse algebraically. So we don't have an XY chart. We are going to actually do it within the equation. That's the new thing you really have to pay attention to. And then we're going to graph that. And then analyze is answer all the questions. Now, I did this all day today, and I will tell you, we're going to do one graph at a time. I tried to put both graphs on there and read it. It got a little confusing. So the one I gave you in your homework, I would do it the way I'm showing you right here, okay? So let's start by graphing the given function. Again, in your calculator, clear. And we're going to type a 2 first, because there's a 2 in front of your log. Alpha math. 2. I like how it puts the cursor in the right place. So we're just typing that in. Let the calculator do the work for us. And graph it. Let's see what that looks like. Oh. Did you like my acting? Oh. Like I haven't seen this before. We're in the negatives over there. I thought we weren't allowed to. Well, notice what happened here. We're going to talk about transformations of log functions tomorrow. But you guys should remember, when you see number in parentheses with an x, that's your horizontal movement and its opposite. This actually moved our graph left 1. So kind of it's going to change our asymptote and all that stuff. But again, we don't need to stress about all that stuff. We're going to let our table help us do a lot of this. Let's pick some good values. Like 0, 0 is a great one. 1, 2 is a great one. 3, 4. Let's do one more over there. 7, 6. Oh, can I see? Let's hope that's 7, 6. Okay, so you can see that curve happening, but what's happening over here? Now we saw it. We know we're crossing over there. We're already touching what was the asymptote on the other problems. So let's go see when we start having an error. There it is. So 0, 0 was our first, however you look at it, good point, and then it goes into errors. That means -1 is your asymptote. And that should make sense to us because it moved the graph from 0 to the left 1. So we have an asymptote right there. Again, that helps us finish the graph. Okay? Now, let's answer the questions about it. So let's put f of x in this column. Domain, I think we're, especially this class, getting the hang of this. The domain would be from -1 now, right? -1 to infinity, not including the -1. The range of these is always going to be all real numbers. There's nothing stopping you vertically. As we approach, as x is going to the right, the y values are going up, right? This one we have to fix, though. We can't approach negative infinity. We're being blocked. So let's rewrite that as the limit of f of x as x approaches. How far can we go? -1, but we have to come from the right. So that's what it should say. And in your homework, I think it actually writes it correctly there. So what are our y values doing? What are our y values doing as we approach -1? They're going down, right? That's what the y values are doing. Where am I? Okay. Asymptote. We have a vertical asymptote at x. Don't forget that. X equals -1. It is 0 on the parent function. We have an intercept at 0, 0, the only place we touch either axis. And concave down, I think you guys would agree. Concave down. Okay. Now, this is the new stuff, okay? I want to remind you of two things we learned yesterday. And the first one is rewriting logs in their other form. And I told you that was going to come up a lot. And this is the easier of the two things you have to do. So given a log, we have to know how to write it in its other form. And that's what we're going to be doing in this problem. But first, whenever we have to find an inverse, we switch x and y. Remember, switch x and y, solve for y. Okay, so this is why I'm going to make it x. Okay, so that's always the first step anytime you're finding an inverse, algebraically. Switch x and y. And then you want to solve for y. There's two problems with this problem. We do have to write the log in its exponential form. They are inverses of each other. And there's a problem. There's a number in here. Yesterday, let me take one of those problems off the page from yesterday. We had really simple ones. When we rewrote this, we started with the base, power over there equals 1.5. We're still doing that, but there's two problems here. One is, when I do that, 2 to the x equals y plus 1, I'm leaving out a number. This 2 has to go to the other side before I can rewrite my log in its other form. So there's some cleanup to do in these problems sometimes. And I'm going to do some homework problems with you, and I'll explain over and over again. But here's what you look for before you can rewrite it. If there's a number after the equal sign, like in between the equal sign and log, we have to move it. Or if there was something hanging off the end here. In other words, what if the problem looked like this? What if I didn't have parentheses around it? That plus 1 would have to get moved before you could rewrite it. The parentheses mean a lot. They mean all of that is together. So this 2 is the only one that's out of place. Again, if the parentheses weren't there, I would have to start out by subtracting 1. Okay? So we're going to see that again. So I'm going to divide both sides by 2 in order to get that to the other side. So x over 2 equals log base 2 quantity y plus 1. Quantity means parentheses. Now it's ready. It looks harder. I mean, it looks more complicated than this one, but it's still the same idea. Start with your base. Who cares if the base is on the right-hand side instead of the left-hand side? It's 2 to the power of x over 2 equals all of that. So 2 to the power of x over 2 equals y plus 1. And remember what we started this all about was to solve for y. Switch x and y, solve for y. So there's one more step in this problem to get the y by itself. So my inverse, remember this is the notation for inverse, is 2 to the power of x over 2 minus 1. So I just rewrote it on the other side. Now, you could absolutely, because now we have to graph this, you could put it in your graphing calculator like we did the log, Or what's an easier, quicker way? What can I do? I heard it. Yeah. Switch. Yeah. Remember, X's and Y's, you can just flip them. So if I know the points here, I think I do, whatever those are, if I just flip them, I have the inverse. Okay? So if I flip, I'll do this one in green. If I flip 0, 0, I get 0, 0. If I flip 1, 2, I get 2, 1. If I flip, I'm trying to see this paper, 3, 4, I get 4, 3. Is that right? Am I doing that right? I can't see. I think so. Yeah, I am. And then 7, 6, when I flip that, I get 6, 7. So far, I have these points right here. What's happening over here? That's where, if you needed to put it in your graphing calculator, you could, but maybe you can understand this, what I'm going to say. Remember what happened here with this red graph? These points right here, if I made one up, like, would it be feasible that one of these points is -1/2, -1/2, for example? Flip it. It doesn't matter what those two numbers are. Two little teeny tiny fractions, both negative. When I flip them, I still have two tiny itty bitty fractions, both negative. So continuing on here, that would be to the left teeny tiny bit, down a teeny tiny bit. And what happens is we get an asymptote of -1s. It's the same number. It's just the other one. It's a horizontal asymptote at y equals -1. So I can see how that part might be a little confusing for students. So if you needed to use your table, you could easily see where your asymptote was. But I think with working with these, you might start just seeing that. Okay, we're almost done. Bear with me. Here's another quick trick for us to finish this. Remember, domains are x's, ranges are y's. Can't we just flip these? The domain of this guy is the range of this guy. And the range of this guy is the domain of this guy. They have the same, notice I'm avoiding end behavior for a moment, same intercept, 0, 0, and it's going to be concave up. That will switch between them. Okay, last thing, end behavior. Okay, this is why it's so hard to do it with two graphs. I start getting confused with which one is which. So I'm looking at the green graph. As my graph goes to positive infinity, my y values are going up, right? What happens when these points go to the left? What are my y values approaching? Are they being blocked? They can't go down forever. They're approaching -1. So that end behavior stuff can be a little confusing, okay? And that's what this is. This is talking about end behavior. Okay? So as the green one goes towards -infinity, the y values are getting as close as they can to -1. They're trying to get to -1 forever, constantly getting smaller and smaller. Okay? Now I'm going to do several homework problems with you. There's two little funky things that I need to make sure you understand. So homework is very, very short. I don't think you guys will have any problem finishing it in class with lots of time to spare. So please write that down. And I'm going to do 3, 4, and 5 with you in part of 7 right now. Okay. Everybody have it written down? Okay, so number 3, that's what you have. Yours is already printed on your paper. Find the inverse. That's it. Find the inverse. Okay, find the inverse. Switch the x and y. Solve for y. Okay, but She said there's sometimes this cleanup. What do I look for? Is there a number in between the equal sign and the log? No. Is there any plus or minus hanging off the end? No. No cleanup in this problem. I can go right into rewriting it in its other form. This is 3 to the x equals y. And if you want to be really proper, notation is for inverse. Okay. Okay, so number 4, switch the x and y, solve for y. Okay, but with log, we have to see if there's any cleanup before I do that. There's nothing in between the equals and the log, and there's nothing hanging off the end. If these parentheses weren't there, I would have to subtract 2 before I start. Okay, but the parentheses is saying it's log of whatever that sum is. Right, so I can just go right into rewriting it. What is the base of this log? 10, right? We know when we don't see one there, it's a 10. So that's 10 to the power of x equals y plus 2. Y is still not by itself. No big deal. Subtract 2 from both sides effortlessly. Okay, number 5 has something a little, not tricky, but you might not have thought of it. Any questions on 3 and 4? Good on 3 and 4? Switch your x and y, solve for y. No cleanup on this one either. So that is 2 to the x equals 2y. Nothing feels weird yet. We have to get y by itself. Divide both sides by 2, but here it is. How do I simplify that? It caught me off guard the first time I did this. I was like, wait a second, how did she get that answer? When I looked at her key, I was like, wait, let me forget it. So here's what I want to ask you. If I gave you this problem, what would you say the answer is? X squared. Yeah. Right? Not a trick question. You all know. I hope when you divide, you subtract your exponents. As long as the bases are the same, we subtract our exponents. That's what we do here. I'm going to take the liberty of putting a 1 here, right, because that's 2 to the first. So keep your base, subtract your exponent. That's it. Keep your base, subtract your exponent. Okay? Oh, for heaven's sakes. Go ahead and do 6 real quick, because I know you're not going to listen to me. There's a part of 7 that I need to go over with you. We learned it yesterday. Oops. This is the answer to 6. So go ahead and take a second and do it if you want to. But do I need parentheses on the 1/2? Yes. I'm doing something to a numerator and a denominator. If there was no exponent there, we wouldn't need the parentheses. Okay. Trust me, I don't think there's anyone in here that wouldn't need help with part D for number 7. So I'm going to do it with you right now. And then I promise to shut up. I will leave you alone, come help you if you need me. I'll stop talking. Okay, so part D in number 7 is find the inverse, like algebraically. So this is your given function. You could fit it like right here if you wanted to find some room to do it. So when we find an inverse, we switch our x and y and solve for y. Now, the example that we did in the notes gave us a log, and when we found the inverse, we wrote it as an exponential. It's reversed now. We're given an exponential. We have to rewrite it in log form. And we learned that yesterday as well. Here's a reminder of how we do it. If you want to write an exponential function as a log, you start by writing the word log, remember? The base of your exponential function is the base of your log function. So what would our base of this log be? 2, right? This is a base, same base here. Remember I said in the beginning, leave a space, and I talked about the loner. The exponent, he's a loner. He's up in the sky. He doesn't like to be with everybody else. So we let him be by himself on the other side of the equation as well. Don't let it bother you that it's not just one letter. Who cares? It's the whole power, and then there's only one number or letter left, and it goes right here. One more step. What would I have to do? Get y by itself. Add, yeah. Good. Remember, don't forget what we're doing in the beginning. We're trying to find the inverse. Switch x and y, solve for y. Just with logs and exponentials, we have this little weird thing. We have to write them in their other form. So the inverse would be log base 2 of x plus 3. Okay? So that's the hardest part of number 7. And I'll put the key up, but I just wanted you guys to have that. Okay? I'll give you a second to finish writing that before I put up. And then if I went too fast or anything, just call me over and I'll help you. Patron, student services. You're probably in big trouble or something.